So we graphed some trig functions. What do the inverses look like? So that's what we're going to do. We're going to start graphing cosecant, secant, and cotangent. Let's see how it goes. All right, so graphing cosecant and actually secant, it gets a little weird, but another way to think about it, this is how I think about it. So I think about, okay, so cosecant I know is 1 over sine. Okay, so we know that. I can remember that, but so this equals 1 over sine of theta. So then I start thinking about, okay, what does sine theta look like, and what are some known quantities that I can put onto a graph? So if we think about our normal coordinate plane, so something like that, and we have just our generic angle. We're going to say that that's 1 with our theta. And so then from there, I can visualize like, okay, so what happens as I move this line down? What happens if I move this line up? And what happens to that sine? So remember, sine is opposite over hypotenuse. So in my imaginary world right now, that hypotenuse is going to stay as 1. Cool, no problem. So as we go down here, as we get theta equals 0, sine equals 0. So theta equals 0, sine of theta equals 0. But what happens when we get to theta equals 0 here? So at that point, sine of theta is 0. That means that we have a 1 over 0 situation. That's bad. We can't do that. So that would be undefined. Anytime in trig functions that you get undefined or you get 1 over 0, we're going to have an asymptote. So that is our first step in graphing the parent function of cosecant. So, and then our period for sine is going to be 2 pi. But so again, I'm looking at my little graph here as well. So it's 0 when it hits here. It's all defined here, but what happens when we have sine over here? So, if we think about, it's a very small angle, so sine is still going to be opposite over hypotenuse. That's going to be 0 again. So at, what is that, pi, or 180 degrees, sine is going to be 0. We're going to have 1 over 0 again. So that means that we are going to have another asymptote at pi. So we're going to have an asymptote every pi interval. So I can put one here, I can put one here, and I can put one here. Okay, so we've got some asymptotes. We got to move on from there. So now let's find like 1. 1 is an easy number, right? So if we were to, again, look at our little graph, and we were to imagine that this line gets closer and closer to the point where it's right here. So in this case, sine, let's see here. Sine is going to be opposite over hypotenuse. So it's just a single line here. So that means that the opposite and hypotenuse are going to be theoretically the same number. They're both going to be 1. So sine of 90 degrees, So sine of 90 degrees is 1. Or sine of, let's see, what is that? Pi over 2 is 1. So now at 90 degrees right here, or at pi over 2, sine is 1. We're going to have, I'm looking at this thing right here, we're going to have 1 over 1. So I can put a dot, pi over 2 at 1. So then, and that's going to be the same as we move forward. So like, let's say if we come over here, what is that? 3 pi over 2. So that is not this one, but that's going to be this one. So if we kind of look at that angle, so sine for that number, or for that one, is going to be, instead of 1, it's going to be -1, because this y value is going down, and the hypotenuse stays the same. It's just a distance. So this is going to be, so sine of 3 pi over 2, which is right here, is going to be -1. So that means I can put a dot here. And then if you were to do a couple other values, maybe using your calculator or whatever, you will find that cosecant looks like a series of parabolas facing away from the center. And again, other than kind of that technique that we just went through, trying to find known values, trying to find undefined asymptotes, that's about as best as you can get in graphing. So our amplitude is undefined, and then our period is still going to be 2 pi, just like it was with sine. So the main steps that I took is that I found known values and I found undefined values, and then I just also kind of remember the general shape of cosecant. So that's how you're going to graph both cosecant and secant. So let's try secant, and we'll see how it goes. And then we're going to put this -1 right there. And then we can finish out our graph. So it helps a lot to kind of sort of know what shapes you're looking for. And that just comes with time, experience, and I don't know, maybe a note card. So we're going to apply the same strategy for cotangent, but now we're dealing with that weird wonky graph, but that's okay. So again, we're just going to try to find some known values, and then we'll fill in the gaps with, learning what the cotangent graph looks like. So our cotangent, remember, is 1 over tangent of theta. So we're looking at this thing again. So I'm imagining, so tangent is opposite over adjacent. So let's see here. When are we going to get to 1? That's a good question. So when are we going to get to 1 is going to be when this side equals this side. And that's when this angle right here is going to be a 45-degree angle, 45 triangle. Or in our case, let's see here, what is that? Pi over... Okay, looking at number 1, you might have noticed an outfit change. Somehow that video got messed up, so we're redoing this one. We've got y equals 3 times cosine of theta. Cosecant of theta. So the periods, remember, just correspond to whatever trig function they correspond to. So cosecant is like 1 over sine. And so our period for sine is 2 pi over b. In this case, b is this number right there, which is an applied 1. So 2 pi over 1. So our period is 2 pi. So from there, we've got it's not an amplitude, but kind of an amplitude of 3 right there. So that's going to come into play a little bit later. But it's really helpful to start to find the asymptotes. So the reason I say that is because we've got 1 over sine of theta. So when sine equals 0, cosecant is going to have an asymptote. So knowing where sine equals 0 is super helpful. So if you know your trig functions, you know that sine of 0 is 0. In which case, if you don't, I just checked it on a calculator because I'm very non-confident about my trig abilities. But anyway, so sine of 0 does equal 0. So that means that this thing blows up, meaning it's undefined, and we have an asymptote at theta equals 0. So that also means that we have another asymptote at 2 pi and at -2 pi. And then if you remember from up top, if you kind of know what a cosecant graph looks like, you know that you're going to have another asymptote halfway in between, because remember we've got, one that goes up, one that goes down. And I'm not saying those are the right ones, so I'm going to delete that, but just knowing what the parent functions look like is very helpful. And I clearly missed on this asymptote. Sorry about that. So that's going to go right there. So now we got to figure out which one's going up, which one's going down. And for that, I don't know. Let's just take a value over here and plug it in and see what happens. It's a sine function, so I can take, it's going to be pi over 2. So I'm going to take sine of pi divided by 2, and that's 1. So this is going to go to 1 at pi over 2. So if this whole thing goes to 1, you're still going to have 1 times 3. So that means that's where the 3 is kind of an amplitude. We're going to put a dot here at 3. So then, since it's on the positive side, it's going up. With that, I'm just going to use the pattern for the rest of it. So -3 down here. -3 down here, and then +3 over here. And there you go. Like I said, it's very helpful to, number one, figure out what inverse that is, and then from there, you can help find the asymptotes of figuring out when that function equals 0. All right, so looking at number 3, y equals cotangent of 2 theta. So step 1, we want to, number 1, find the period, and number 2, it'd be nice to kind of remember what the graph kind of looks like. So cotangent is related to tangent. It's the opposite of tangent. And if you haven't done this already, I would make a little note card of some of the different periods and things like that, because I get them all confused all the time. But cotangent is related to tangent, so we're going to use that as our period. And then the equation for that is pi over b. In this case, our b is 2, so we're going to say pi over 2 is our period. This is helpful because now we know, once we find one thing, we know that it repeats every pi over 2 radians. So anyway, it also helps to kind of remember what the graph looks like. If you remember, graph looks like that. And so now, next step is I want to find some asymptotes. Once we find one, we can then repeat it and figure it out from there. So we need to figure out where this equation blows up. So remember, cotangent is the same as 1 over tangent of 2 theta. I always start with 0, just because if I get lucky, great. And usually 0 is a pretty good place to start. Also, if you notice, oh look, 0 times 2 is still 0. So if you either draw a picture and figure out that tangent of 0 is 0, or I just threw it in my calculator just to see. So tangent of 0 is in fact 0. So that means that this is going to be 1 over 0. So that is undefined, which means that we're going to have an asymptote at theta equals 0. So because I know the period already, I can very quickly add the rest of my asymptotes. We'll go this way too. So then, if you remember, that point is directly in the center. So if we just look at what's halfway between this and 2 pi, that's going to be like pi over 4, but we also just have a line there. And then you just draw one going up, one going down. Now when I'm grading these, I'm going to look at this one very closely to make sure that it's correct. The rest of these, I'm just going to make sure that they're on the page. So you don't have to make them perfect. You just have to show me that you kind of understand that this is a cyclic equation and it repeats. So there you go. Cotangent of 2 theta. So I'm skipping down to number 7 because number whatever that is I'm skipping is another cotangent. So I wanted to show you a different function or give you as many examples as I can. So we're looking at y equals 2 times secant of 2 pi. All right. Step 1, let's figure out our period. Let's see here. Secant is like, I'm just going to write this down, 1 over cosine of 2 pi. I'm looking at my note card. Sine and cosine, the period is 2 pi over b. b in this case is this number right here. So it's going to be 2 pi over 2, which is just pi. Again, this is very helpful to once we find either an asymptote or whatever, it's going to repeat every pi, right? Yeah, every pi time. Okay, so now I need to either A, find an asymptote, or B, figure out some of the points. If you remember, and I would look back up there, but the secant graph is going to be the one that kind of looks like this. You got one going up, one going down, so on and so forth, with an asymptote in the middle. So some nice things that I would like to find is the asymptote, or that point, something like that. So step 1 over 2 cosine of theta. So like I've told you before, I always start with 0. So cosine of 0 is 1. So when theta equals 0, it's going to be normal cosine of 0. So we're going to have a point at, what is that? Y equals 1. However, we have this number out here. This is kind of like the amplitude. Not really the amplitude, but kind of. So when secant of 2 pi equals 1, instead of putting a dot here at 1, we're going to put 1 at 2 because it gets multiplied by 2. Okay, so that's helpful.